Alright guys, so this is a video for section 8.2 and 8.3, and we're kind of combining these because they have the same concept. Okay, that way we can focus on them together rather than one at a time. It's just easier. Okay, now remember when we did triangle congruence theorems, we needed like side angle side, side side side, angle side angle, things like that. This is very, very similar to it, except we have a couple different theorems, and we're talking about how we're proving triangles similar. So once again, same concept, just I guess a little different approach. So let's look at these prerequisite skills first, okay? Just to kind of remind ourselves of a few things. So here we have these two lines are parallel. Okay, well, we know if these two lines are parallel, corresponding angles are congruent. Okay, and then if I look at this triangle here, okay, I know I have three angles. One's x, one's 58, one's 32. And every triangle, all three of these angles have to sum to 180. So I could set up an equation, say x plus 58 plus 32 is equal to 180. Well, 58 plus 32, if my mental math is correct, is 90. So then I'd get x is equal to 90. Okay, now I want you to look at B and try to figure B out on your own. So pause it, work it out, and then we'll come back to it. All right, guys, so on B, hopefully you finish this up. Okay, remember the blue highlighted are vertical angles. This is back to chapter 1. You should know this. Okay, and we know that vertical angles are congruent. So if this here is x, this has to be x. Okay, then we can focus on, let me highlight it here. This triangle right here. Okay, if we know this angle's 90, this angle's 34, this is x, we can set up an equation. X plus 34 plus 90 is 180. Solve for x, we get x is 56. All right, so these are the three theorems that we can use to prove triangles are similar. Okay, so what we're trying to do in this section, or these sections, is to prove triangles are similar. Okay, and remember, similar triangles is very different than congruent triangles. Similar means same shape, different sides. Okay, so the first and the easiest one is just the angle-angle similarity theorem, or we can do AA-sim. Okay, that's kind of how I abbreviate it. And ultimately, what we're thinking of is if we can get two angles of one triangle or congruent to two angles of the other, that means that's all we need to prove that the triangles are similar. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in this case, if angle B is congruent to angle E, which is shown that they are, and it also shows that angle A is congruent to angle D, we need to know nothing else to know that these triangles are similar. And remember, here's the definition, or the symbol for similar. Okay, the next one is the side-side theorem. Okay, and this is same but different than our other side-side theorems. Okay, because remember, the side lengths are not the same if the triangles are similar. They're different, they just have the same ratio. Okay, so if the ratio of all side lengths of two triangles are congruent or are equal, then the two triangles are similar. Okay, so let's go ahead and highlight corresponding sides. So like these two would be corresponding, these two would be corresponding, and then the bottoms would be corresponding. Okay, so if I find the ratio of AB over RS, okay, that would be the same as, okay, the green, AC over RT, which would be the same as the blue, BC over ST. Okay, if you know all those sides have the same ratio, okay, then that means the triangles are similar. Okay, last but not least is the side angle side similarity theorem. And once again, this is very similar to the side angle side congruence theorem. but slightly different because the side lengths are not the same. So once again, remember the way it's written, we know the angle is between the two known sides, meaning that the two sides we need are on each side of this angle that's congruent. So this side and this side would be corresponding, and then this side and this side would be corresponding. All right, so let's fill this out. Okay, so if an angle of one triangle is congruent to an angle of a second triangle, and the ratio of the sides including these angles are congruent. Now remember, there's two sides. I'm going to put both sides as in two pairs. Okay, then the triangles are similar. So in this case, if xz over mp is equal to xy over mn, and the angles are congruent, so angle x is congruent to angle m, then the triangles are similar. Okay, but remember, this all comes down to it has to be the included angle that we know is congruent. The angle has to be middle. All right, so let's look at some examples. Okay, it says determine whether the triangles are similar. If they are, write a congruency statement. So remember, to determine if they are similar, we only need two pairs of congruent angles. Okay, so in these two triangles, we have our 90 and 90. Okay, now I don't know, 26 and 64 obviously aren't congruent, but I don't know, maybe this is 64 and this is 26. We don't know. So I'm going to go ahead and find the measure of this angle by just saying if this is x, let's say 90 plus 26 plus x is equal to 180. So 116 plus x is 180. And then if we subtract 116 from that, you do get 64. 64. So this is 64 degrees, okay? Now, yes, I can see it wasn't obvious at first, but they do have two congruent angles. So I can say, yes, these are similar by, and if the two angles are the same, that would be the angle similarity. Okay, so I want you to pause this video and I want you to do B on your own, and then when you're done, replay it and we'll go over the answer. All right, so I've worked this one out. Okay, so you can take either one. I've taken the one on the right to solve for the missing angle, and I got that it's 98 degrees, okay? And notice that this one's 99, okay? So we're 1 degree off, so they're very, very close, but no, they're not exact, and in math, if they're not exact, it's not equal, okay? So they only have one pair of congruent angles, and therefore they don't have the two that we need, so no, these are not similar triangles. Okay, so let's look at example 2 now. Okay, it says, is either triangle DEF or triangle GHJ similar to triangle ABC? So we're checking to see if this is similar to ABC, and we're checking to see if this is similar to ABC. Okay, now I know yours is probably in black and white, okay, but if they are similar, the shortest sides would all correspond. Okay, the longest sides would all correspond, and the medium sides would all correspond. Okay, now they are color-coded in color, but like I said, you probably have black and white, so I went ahead and color-coded them. Okay, so in this one, all we have are side lengths. Okay, so the only way that we can do these is check for the side similarity theorem. Okay, we want to see if the ratio of all three sides are the same. So let's go ahead and look at these two. Okay, what I want to know is 8 over 6, is that equal to, and I'm going to put a question mark, 12 over, I didn't highlight that one, 12 over 9. And is that equal to the blue 16 over 12? Okay, if I reduce all these, that's 4/3. That's 4/3. 16 over 12 is also 4/3. So, yes, these two triangles are similar by side, side, side. So, triangle ABC is similar to triangle DEF by the side, side, side similarity theorem. Okay, well now I want to check the last one with triangle ABC. So once again, I'm going to do the same thing. So 8 over 8, those are the same. Is that equal to 16 over 16? So far, so good. Is that the same as 12 over 10? Okay, now most of you can stop there, but we'll go ahead and finish it. So 8 over 8 just reduces to 1. 16 over 16 reduces to 1. 12 over 10 is not 1. It's what? 6/5. Okay, so no, these are not similar because only 2 of the 3 corresponding sides have the same ratio. Okay, and in parentheses we need all 3. Okay, side, side, side means all 3 sides, all 3 corresponding sides have to be the same.